belakang ya di sekolah ya, yang di sekolah. Baik, terima kasih. Siapa lagi belum sebut ya? Nih, Mbak Duta FKIP, Mbak yang sangat luar biasa. Terima kasih. Alhamdulillah hari ini kita diberi kesehatan, diberikan nikmat, sempat, sehat dalam hidayah Allah, dan mudah-mudahan kita senantiasa diberikan keberkahan sepanjang hidup kita. Amin ya rabbal alamin. Pertama-tama ingin saya sampaikan permohonan maaf dan salam dari pimpinan kami, Bu Uspa dan Pak Ferry, bahwa ada kegiatan lain, dan juga saya sampaikan kepada Bapak Ibu semua bahwa pada hari ini ada kegiatan yang sama-sama penting juga, yang untuk keberlanjutan FKIP ke depan. Kita doakan semuanya berjalan lancar ya, karena apa namanya, bulan Januari ini kita harus gaspol semua nih kegiatan-kegiatan ya. Sekalipun anggaran belum turun, tapi kita sudah mulai rencanakan rencananya ke depan seperti apa, seperti itu. Menyampaikan salam juga dari Pak WD2 yang kebetulan juga mendampingi Pak Deka. Mengucapkan terima kasih sekali atas kehadiran dari Daud dan dari Arizona State University, Bapak Ibu semua yang hadir hari ini. Semoga lain waktu beliau bisa bergabung bersama kita semua. Saya hari ini sangat tertarik sekali, Pak, green chemistry, Pak. Biasanya kimia tuh, saya udah orang biologi, Pak. Kimia tuh yang paling sering dituding, ini perusak lingkungan nih kimia ini. Adanya resistensi, adanya resurgensi, itu kimia semua. Iya kan? Adanya koevolusi, semua itu kimia. Nah hari ini pendidikan kimia bekerja sama dengan Dao dan Arizona State University membuka mata kita semua ya, 2 hari ya, hari ini tanggal 4 dan tanggal 5 ya Pak Irhamni ya, akan berkegiatan bersama ya. Di sini ada collaboration, ada sustainability, sangat luar biasa nih. Kan kalau kita lihat banner di depan ini, itu kata kuncinya tuh dalam semua itu, ada inovasinya ya. Dan tadi permasalahan-permasalahan yang disampaikan oleh Prof. Pawan tadi itu menjadi salah satu catatan bagi kita bahwa solusi itu butuh melalui sains ya. Kita melalui apa yang sudah kita pelajari ya, bahwa kalau kemarin ada banyak yang mengalami resistensi, resurgen dan lain-lain, oh ini sekarang ada loh green chemistry, yang mana tadi kata Pak Ferry, sebenarnya kimia itu memang agak bahaya, tapi bagaimana cara mengelolanya, ini yang paling penting. Nah jadi kita bersama-sama untuk berkolaborasi ya, menyelamatkan bumi ini tentu saja ya, mulai dari pendidikan ya. Kenapa diundang guru-guru? Karena pendidikan itu adalah pintu masuk yang paling efektif menyampaikan pesan apapun itu, baik ilmu pengetahuan, pesan moral, pesan etika ya. Karena apa? Karena pendidikan guru itu siklusnya berjalan terus, mulai lagi dari awal ya. Ada murid kelas 1 masuk, naik kelas 2, kelas 3 udah belajar kimia, datang lagi kelas 1, kelas 2 belajar udah pintar kimia, datang lagi, begitu terus ya. Nah, oleh karena itu ini sangat bagus sekali ya kemasan kegiatan hari ini, melibatkan guru ya, melibatkan guru ya, pendidik juga calon pendidik ya. Jadi nanti ini jadi mahasiswa Untirta di FKIP yang akan menjadi guru ini akan selalu teringat kegiatan hari ini. Dan kami sangat terima kasih sekali ini. Mudah-mudahan kegiatannya berlanjut ya Pak Ferry, Bu Puspa ya. Ini mungkin workshop yang pertama, nanti selanjutnya yang kedua dan seterusnya ya. Mudah-mudahan kita bisa mengembangkan sayap ya, mungkin bukan hanya di Cilegon saja ya Pak ya. Karena Provinsi Banten ini 8 kabupaten kota hampir semuanya terdapat industri besar, industri raksasa. Cilegon, Kabupaten Serang, Kabupaten Tangerang itu apa namanya, sangat ini sekali, industri kimianya sangat banyak seperti itu. Nah ini kita pertama daerah Cilegon. Mudah-mudahan kedepannya kita bisa merangkul teman-teman kita dari apa namanya, instansi pendidikan yang di daerah yang lain seperti itu. Nah untuk sekedar informasi Pak Ferry, Bu Puspa, bahwa FKIP ini adalah fakultas yang paling gemuk dari fakultas yang ada di Untirta. Dari 7 fakultas, FKIP paling gemuk ya. Jadi sepertiganya di Untirta itu ada di FKIP. Wah, jadi sangat luar biasa. Kita ada 75 jurusan, 73 jurusan, 23 jurusannya ada di FKIP. Tepuk tangan dong buat itu. Kebayang ya, kalau dalam sisi demografi semakin banyak penduduk itu banyak masalahnya. Kalau kita nggak apa-apa banyak masalah, kita beresin ya Pak Robi ya. Ya, mudah-mudahan semuanya bisa berkolaborasi. Itu kan juga kolaborasi ya, karena nggak mungkin kita menyelesaikan hanya dengan dua tangan kita. Pasti kita harus kolaborasi seperti itu. Nah, jadi mahasiswanya juga seperti itu Pak. Ya, paling 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 banyak di FKIP. Sekarang ini kita ada sekitar 12.000 mahasiswa di FKIP. Luar biasa ya. Jadi kalau kita KKM, GPR itu semuanya hampir didominasi oleh mahasiswa FKIP. Jadi tepat sekali kalau Daud dan Arizona University, State University ini menggandeng FKIP karena dampaknya itu kanan kirinya itu cukup kena, cukup banyak yang kena seperti itu kalau kita lihat efek dominonya seperti itu. Jadi demikian mungkin sekilas tentang FKIP. Terima kasih sekali lagi atas kehadirannya semua dan atas kontribusi semuanya di sini. Kita semangat membangun Banten, semangat membangun FKIP, dan karena diberi amanah dari buka acara ya. Jadi marilah kita bersama-sama mengucapkan Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Dengan demikian secara resmi Green Chemistry Workshop secara resmi dinyatakan dibuka. Selamat melaksanakan workshop 2 hari ini sampai besok, dan tadi ada 4 paket langsung praktek, ini sangat luar biasa. Terima kasih. Mohon maaf kalau sarana dan prasarana yang ada di kami sangat-sangat terbatas ya. Mungkin sangat terbatas, malu banget ya Pak Robi. Kita berharap 2027 nanti itu yang di seberang pintu masuk itu sebelah kiri itu akan terbangun 4 lantai gedung khusus laboratorium. Doakan kita mendapatkan begitu ya. Bismillah. Ya, ini rencana ke depan seperti itu. Nah, mereka udah lulus katanya. Nggak apa-apa ya, kan itu kan untuk motor kalian ya. Demikian selamat melaksanakan workshop dan saya akhiri. Bila taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Berikan tepuk tangannya kembali untuk Ibu. Terima kasih banyak kepada Ibu Dr. Haji Enggar dari SSI MSI atas sambutannya serta membuka acara kali ini. Sebagai bentuk apresiasi dan ucapan terima kasih, acara selanjutnya yaitu penyerahan Token of Appreciation dari Universitas Sultan Agung Tirtayasa kepada Dow Chemical Company dan Arizona State University. Mohon izin Bapak Ibu kepada Ibu Enggar dan Bapak Ilhami untuk berkenan memberikan Token of Appreciation-nya kepada Dow Chemical Company dan Arizona State University. Baik, mohon izin untuk memandu ya Bapak Ibu. Baik, dalam hitungan 3, 2, 1. Sekali lagi. Dalam hitungan 3, 2, 1. Sudah? Baik, berikan tepuk tangannya kembali. Baik, untuk peserta boleh untuk berdiri. Mohon izin Bapak Ibu semuanya untuk dapat berdiri melakukan sesi pemotretan. Kepada tim dokumentasi, untuk siap untuk memotret. Kepada tim dokumentasi dipersilakan untuk melakukan sesi pemotretan. Baik, persiapannya Bapak Ibu serta rekan-rekan semuanya, apakah sudah siap? Mungkin yang di belakang jika tidak terlihat bisa berdiri. Baik, Bapak Ibu sudah terlihat? Apakah sudah terlihat semua? Sudah jelas bagaimana? Mungkin kita menggunakan kamera terlebih dahulu ya. Mungkin Ibu izin untuk lebih merapat yang ada di ujung-ujung untuk lebih merapat kembali supaya terlihat dalam kameranya ya. Iya. Ya, mungkin yang masih di ujung boleh lebih merapat Bapak Ibu karena masih sedikit tidak terlihat. Apakah sudah aman? Aman. Oke, izin memandu ya Bapak Ibu semuanya. Dalam hitungan 3, 2, 1. Untirta Jawara. Untirta Jawaranya jangan lupa. 3, 2, 1. FKIP, Sekolah Jawara Indonesia. Oke, siap semuanya. Dalam hitungan 3, 2, 1. Baik, mungkin kita ganti menggunakan handphone ya. Untuk gaya DAW, bagaimana Bapak? Gaya diamond, apakah bisa gaya diamond? Oke, sudah ya. Dalam hitungan 3, 2, 1. Kita ganti handphone terlebih dahulu ya. Harap sabar. Oke, siap semuanya. Dalam hitungan 3, 2, 1. Ganti handphone lagi. Mungkin ini handphone terakhir? Iya, ini handphone terakhir. Oke, siap semuanya. Dalam hitungan 3, 2, 1. Tunjukkan ekspresi bagiannya. Oke, terima kasih. Baik, alhamdulillah, Bapak Ibu serta rekan-rekan semuanya, untuk acara pembukaan telah kita lalui bersama dan berjalan dengan lancar. Untuk sesi selanjutnya, yaitu kepada hadirin semuanya, dipersilakan untuk menikmati coffee break terlebih dahulu, kurang lebih selama 10 menit. Nanti akan kita lanjut dengan sesi workshop. pictures also. I don't have like in a picture.
Oh ya, foto sama persembahan. Iya benar. Ibu, makasih datang. Robi, Bayu ya, suami.
Baik, mohon perhatian kembali kepada semuanya, karena di sini kita akan melanjutkan ke sesi workshop. Karena tadi setelah kita mendapatkan coffee break, semoga semangat kita bisa kembali fokus untuk mengikuti rangkaian acara kita hari ini. Nah, sebelum itu, sebelum kita langsung masuk ke dalam pemaparan yang akan nanti langsung dijelaskan oleh Profesor Supawan, di sini kita kedatangan yang sangat luar biasa. Beri tepuk tangannya kepada Ibu Laurencia dan tim. Nah, beliau ini yang akan nanti memimpin kita secara langsung untuk melakukan sesi bersama Profesor Supawan. Kepada Ibu Laurencia dan tim dipersilahkan untuk bisa memberikan sambutan ataupun perkenalan kepada para hadirin sekalian.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Bapak, Ibu, guru, serta calon guru, mahasiswa FKIP Kimia Untirta yang kami banggakan, Bapak Ibu dosen, para pimpinan di FKIP yang kami hormati, dan rekan-rekan sekalian yang saya sayangi, kami akan perkenalkan diri. Kami adalah alumni untuk workshop Green Chemistry, khususnya Small Scale Chemistry, sejak 2018 hingga sekarang. Kami terus berlatih setiap tahun itu, insya Allah diberikan beasiswa oleh Prof. Supawan and Team untuk belajar Small Scale Chemistry di Thailand. Kemudian kami implementasikan di pembelajaran di sekolah masing-masing. Kemudian kami juga aktif mengikuti berbagai kegiatan konferensi seperti ICCA, PECON, atau ACC in Thailand, dalam rangka kita mempublikasikan penelitian kita terkait small scale chemistry and education. Jadi kita menerapkan pembelajaran dengan menggunakan small scale chemistry. Perkenalkan, nama saya Laurencia, dan ini yang sebelah kiri saya.
Perkenalkan, saya Ipo Dardianti, saya guru kimia juga dari SMA Negeri 1 Ciamas, Kabupaten Bogor.
Saya lupa kalau saya dari MAN 3 Jakarta Pusat.
Nama saya Nurul Kholis dari SMA N1 Campaka Purwakarta, Jawa Barat, Sunda Empire. Mangga dilanjut.
Terima kasih. Perkenalkan saya Dr. Tuti Alawiyah, SPD MPD. Saya awalnya guru kimia, tapi sekarang sudah menjadi pengawas di Kabupaten Bogor. Terima kasih.
Perkenalkan, nama saya Fiut Podria. Saya biasa dipanggil Ibu Fiut. Saya dari SMA 10 Kota Bekasi.
Demikianlah para peserta sekalian, perkenalan dari kami. Selanjutnya kita akan mengikuti opening speech about green chemistry dari Profesor Supawan. Sekaligus kita langsung praktekkan. Jadi nanti dimohon kepada teman-teman sukarelawan ya dari DOW dan juga teman-teman dari Untirta untuk membantu memberikan handout paper untuk peserta dan juga alat-alatnya sebelum Prof. Supawan memulai, karena nanti kalau dia udah mulai itu langsung praktis, itu langsung kita praktekkan. Demikian. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Baik, Ibu, mohon maaf izin jangan dulu duduk terlebih dahulu. Kita akan melakukan sesi pemotretan terlebih dahulu. Mohon izin untuk Bapak Ibu dosen untuk berkenan melakukan sesi pemotretan bersama Ibu Lorencia dan tim. Dan kepada tim dokumentasi untuk siap melakukan sesi pemotretan. Baik, sudah siap semuanya Bapak Ibu? Mohon izin memandu dalam hitungan 3, 2, 1. Lagi, sekali lagi. Gaya chemistry. Oke, siap. Dalam hitungan 3, 2, 1. Sekolah Jawa. Untirta Jawara. 3, 2, 1. Berikan tepuk tangannya kembali kepada Ibu Lorencia dan tim. Nanti para Ibu Lorencia dan para tim yang akan mengikuti kita secara langsung untuk melakukan sesi bersama dengan Profesor. Oke, setelah tadi kita berkenalan dengan Ibu Lorencia dan juga tim di sini, kita akan langsung masuk kepada sesi workshop bersama dengan Profesor Supawan. Okay, so we now move on to the next session, Introduction of Green Chemistry Workshop, a session highlighting the role of chemistry in advancing sustainable and environmentally responsible innovation. This session will be delivered by Professor Supawan Tantayanon, a professor of chemistry with extensive contribution to the field of green chemistry. To Professor Supawan, time is yours.
Okay, good morning again. Okay, can you hear me properly? Yes. All right. Okay, let me share my slides, and I try to cover the meaning of green chemistry, sustainability, and chemical safety along the way. Before we're going to have a hands-on workshop. Thank you for Dow and ASU, Dow Indonesia and ASU, and the university that hosts this second green chemistry and small-scale chemistry workshop. Unfortunately, I'm not there, so it's a bit not so enjoyable because I didn't participate and see you in person. But anyway, with the technology, we can transfer our knowledge and the skills and experience to you all. As I mentioned during the opening ceremony, that we need help, we need we need the teachers to be able to help this work. How? Let's see. Okay, look at the workshop. Okay, this workshop is supported by the Chemical Society of Thailand and Department of Chemistry, Faculty of Science, Chulalongkorn University, Thailand. Okay, so the first part that I would like to do is introduction about green chemistry and sustainability education. I put this slide just to tell you that here our planet is very important and no other planet beside the Earth that we can live on. In the picture, in fact, I invited this Professor Albert Sacco from Worcester Polytechnic Institute. He was astronaut of NASA, and I invited him to visit Thailand in 1996, not the year, 1996. And this picture is of our two sons at that time. So it's long time ago. We already realized that we have to preserve and protect our planet's magnificence for generations to come. As mentioned before, that the nature is not just to give us beauty, but it also a lot of natural resources that we can use for our daily life. And what we have given to our nature, that is, we use more natural resources, much more in our generation, and that will the deforestation, ecosystem decline, the degradation of land, and loss of biodiversity, and many other things more. And you can see that right there now what the nature reacts back to us. So more frequent wildfires, longer periods of drought, increase the wind intensity and rainfall, and many other things happen all over the world. So that's why we need to solve this problem. And you can see right away that I want to show you today that chemistry really play a role. If we use it incorrectly or not properly, then it can cause problem. But at the same time, chemistry can solve this problem. So green chemistry meaning is the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. That means we would like to encourage you and the next generation that whatever you're going to do, you have to start thinking at the beginning, not let the effect happen later. So why green chemistry? It's just chemistry, but we look at green in a way that the green is bring us to nature, to growth, to harmony, to wealth, and to stability, the stability. So to do work on green chemistry, we have to think about the future. I show you this picture that green chemistry has been introduced to Thailand and perhaps in Asia in 2002. It is originated in the USA, the United States. And you can see that is in 2002. Well, this is in 2001. This is the first time that I learning green chemistry in Boulder, Colorado State University in the US. And then 2002, I invite all these gentlemen and lady, a group of Green Chemistry Institute of American Chemical Society to visit Thailand. That happens in 2002. And I became coordinator of the Thailand chapter there for GCI, American Chemical Society. And this is a kind of Bible book, Green Chemistry, that is written by the two fathers of green chemistry, that is Paul Nestas and John Water. So we have been working together since 2002 until now. So recently, they came here to Thailand and they will come again this year. And this is a book, Green Chemistry Theory and Practice in Thai. So I translate into Thai. Okay. So green chemistry, there are 12 principles in green chemistry. You can search through the internet and read about the detail of each principles. But in summary, these principles of green chemistry, looking at in the area of toxicity, that is talking about reducing hazard, talking about feedstocks, we should use renewable resources instead of using crude oil and natural gas. But of course, this is just a certain thing that we can find the other way. Can you hear me properly? Is that okay? Let me know because I don't know what's happening there. So the main focus on 12 principles of green chemistry, we're looking at the designing safer products. Biodegradability, that means that after use, then it should break down into things that not harmful to environment. And we also look at energy, accident, efficiency, of course, a shorter route for synthesis, and also using lower temperature, lower pressure, and no accident. So you can see that the principles of green chemistry, we focus on the good health for people and also trying to reserve our natural resources and the health of the environment as well. Today, the industry really trying to clean up all the waste, right? But still use a lot of chemicals, and the process is still use those very high temperature and high pressure. So 12 principles of green chemistry is really written for industry because the amount of the chemicals that they use. So with the 12 principles of green chemistry, they talking about change the way of thinking. Instead of looking at the circumstantial, how to use, how to protect, how to handle, how to treat, right, after use, but rather think before, looking at the molecular design, choose the one which has less toxic, and during the process, no toxicity, reducing the hazard, that's it, right? And also thinking of chemical safety, right? Try to prevent problems, accidents from the property of the chemical itself. And of course, doing green chemistry is going to earn more profit. Okay. Right, so these are the benefits. If you do green chemistry, then the environment is much better. Human health is also good health, right? The economy also grow, and of course sustainability, right? Since we try not to destroy all the natural resources, right? And for science, then learn more insight, fundamental new insights. So these are the benefits if you do green chemistry. So let me conclude that benefits of green chemistry. If we do green chemistry, that means we have to reduce risk, and risk is a function of hazard and exposure. If you reduce risk, you have to reduce hazard and exposure. But green chemistry, looking at the hazard at the beginning, we choose the chemicals that less hazardous or non-hazardous at the beginning. So if you use a less hazardous at the beginning, during the process, you should not have any problem. And waste come out, it also friendly to the environment. So mainly focus on reduce the hazard. And now many industry in all sectors help, go green. They do follow the 12 principles and look at academy. We also should do that, go green as well. Not just only do research lab, but now I will bring you to the teaching classes using the experiment that really green experiment. So let me conclude that green chemistry talking about reduce the material risk we're going to use, reduce energy, reduce risk and hazard, and reduce costs, reduce waste. Okay, so the heart of green chemistry is seeks to reduce and prevent pollution at its source, at the beginning, the design and process. So right now, as you know, that working with chemicals is a kind of take risk with the hazard of the chemical itself. So in the industry and in fact the university and school, you should have engineering controls, you should have administration controls and PPE. But this control is least effective. It's gonna be the best if you do elimination and substitution. And you can do that by using the 12 principles of green chemistry. So in our academy world, teaching chemistry with hands-on to expose the students and teachers exposed to chemicals, and that the risk come in. The risk is function of hazard and exposure. So in small scale chemistry, we do reduce the amount of the chemical used. That means the exposure is lower, and at the same time we select the chemicals that is less hazard. So two together, lower hazard, lower exposure, then it's lower risk, and it's good for us. Even though they said talking about using PPE, but PPE does nothing to stop the hazard. It just simply protect the person, and to reduce the severity of the potential accident. Okay, all right, so now we come to integrate green chemistry in education. And that means that we will have safer laboratory practices. And doing that, then we open up the opportunity for the students to have creativity and innovation when they grow up. And this, of course, aligns with SDGs. And in a sense, it's inspired this responsibility and ethics inside at the same time. So green chemistry is really related to sustainable development. What is sustainable development means? It means a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. The next generation, that means your students. When they grow up, they understand about green chemistry and sustainable development, then their lives will be, fruitful and happy. No accident cause of harmful in working with chemicals, working in the process to produce the products for our daily life. And that's why SDGs come, because we need to solve all the problems, the global challenges that we face right now, not just only pollution, climate change, environmental degradation, but we're looking at also poverty and inequality. Right now, I would say that more than 90% of our students in schools still don't have a chance to do experiments properly. safely, and also comparing to the schools that has a kind of a budget, good budget, but the small schools and remote schools, they lack of that. That is inequality in science education. And to solve the problems for the world challenges in the future, you need the input of science and technology. Okay, I just list that small scale chemistry directly supports multiple SDGs. It's not just only education, but it's sustainability in action too. Okay, so I just want to stop here for the meaning of green chemistry and the sustainability education. So let me go to the second slide. The second one. I don't see it. Any questions? Any comments? Any opinion? Please let me know. Okay, so now I want to bring you to a small scale and green chemistry experiment. And I will focus on chemical safety and the small scale chemistry technique. I believe that you are teachers and you want your students to have experience with hands-on experiments, because we should allow the students to, not something that is done to them, not just show them, not just explain, not just demonstrate, but let them do. As you know, you heard about this, I hear, I forget, I see, I remember, I do, and I understand. So we need that to allow the students to do by themselves so they understand. And that is objective of teaching a laboratory experimentation. It's not just learning science, not just learning the context of science, but it's also develop other skills. So teaching science in school to be meaningful, interesting, and accessible to students has to be primarily experimental. The practical work or doing experiment by themselves, it is developing the curiosity, the critical thinking, and of course scientific literacy to our youth or our students. And then they will appreciate science more in real life when they grow up and they solve the problem. However, as is mentioned before, mostly in schools cannot offer to do experiment. So no experiment, no interaction, no excitement. Then science becomes abstract and disengaging. And that will affect the future, because the student is going to be reduce the interest in science careers, limiting our region's capacity to develop future scientists, engineers, and innovators. So let's come and help to engage the students to love science and learn science. The abstraction about doing experiments chemical experiment is because the nature of the chemical itself, which is, I would say, every chemicals are hazardous, but some lower hazardous, the other is stronger hazardous. So you should know the property of the chemicals before you use. And that is why we need a laboratory, because what we doing right now in a traditional way, we use high amount of chemicals. And these chemicals can be harmful to people in many ways. But I will just pick up only about flammability, about fires, about flammables, toxic chemicals, and reactive chemicals. So you should know when you work with the chemicals, there is a possibility that the accidents can occur when we work with the flammables, like in schools, because of the budget, you cannot afford to have the other type of heating tool. The cheap one or the inexpensive one is the alcohol burner, but there is a flame. So the flame can cause the fire easily because this fire triangle, if you understand this fire triangle, then you know how to prevent fire happen. See, it said that burning is the oxidation reaction. In the oxidation reaction, you need fuel, or the one is oxidized and the one is oxidizer. If they come together, fuel and oxidizer, and there is a flame or ignition source, then it's complete the fire triangle. This is a fire triangle theory. That is why fire happens. However, there must be the proportion of oxidizer and fuel. Fuel, this can be mean the chemical itself, or it can be in general just papers, wood, anything, material can be burned, but some can burn quickly, some cannot burn quickly. It depends on the property of it. But chemicals can be fuel too. So with those solvent that we use, alcohol, acetone, there's a higher volatility than the other chemicals. So that means that in the room, once you open up, then the vapor fill up in the room. And wood oxidizer is around us. That is oxygen in air. It's already there. One triangle, one side of this triangle is always there, everywhere. That is oxygen in the air. So if you allow the vapor of the chemicals to mix with oxygen in the air to a certain proportion, and there is an ignition source coming, fire will happen. Okay, so that's why I would like to say that you should not use alcohol burner, because flame can cause fire very quickly. Now, if you think a little bit more about small scale chemistry, you use less amount of chemicals. That means the chemicals still the same one. Vapor still the same, vapor pressure the same, but the amount was reduced into 1,000 times much more lower. Then vapor also reduced, and it's never reached to the point where fire can happen. Okay, did you get me my point? Okay, so small scale can help to reduce the possibility of getting fire or accident in fire. The second group of chemicals is toxic chemicals. If these chemicals in the bottle tightly closed, it should be okay. But did you know that even though you close the bottle, you still can smell the chemicals? That means the vapor can come out because this molecule, we're talking the molecule is very tiny, tiny. It can go around the thread of the bottle and the cap and come out to the room. So if you open up, more vapor come out. If you pour it into the beaker and let it sit on the bench, more vapor go out to the room, to the environment. And we walk in or we work with chemicals, that means chemicals go into your body automatically because you have to breathe all the time. That means you bring up the vapor of the chemicals into your body. You cannot avoid it. So, but if you reduce the amount 10,000 times lower than the traditional one, the vapor still come out, but much less, 1,000 times lower than the traditional one. So if you smell it, if you can smell it, that means it's going to your body. But if it is you don't smell it, that means you are safe or better, in a better position. If the chemicals into your body only need a bit, it would be okay. And if you use brain chemistry principle, you choose the chemicals, then you are safe. Okay? So the mode of entry to your body is not just only inhalation, it also by absorption. That's why when the chemicals contact to your body, the chemicals can get into your body and spread out to blood vessel all over your body. So that's why they recommend you to use gloves. And if you use gloves, it has to be with the gloves that with the material, correct material. You cannot use just only the cloth glove or just a rubber glove. You have to look at, find the information how to protect yourself. You must use a nitride glove if those are organic chemicals, something like that. But that's costly, right? And you cannot afford to have the students who have all these gloves, a goggle, right, to protect, and also the lab gown. But for lab gown or lab coat, you can use maybe ask the student to bring the father's old shirts. That also can be used, but make sure that it's tied well, not so loose. Otherwise, then it can cause other accident as well. Okay, so now you can see, right? If we do small scale chemistry, it helps in many things, right? It's reduce uh, the way of exposure to the chemicals, and that's protect yourself automatically. The third way to get into your body is by digestion, but it's not just happen automatically. Normally, it's by accident. Your hand is contaminated with chemicals, and then you take food and put in your mouth. Then that is go to the digestion system and can harmful to your body as well. And the last one is injection. Oh, I thought that I changed it. Injection. I always miss this. Huh? Injection. That means a accident, like a broken glass, broken bullet, broken pipette that is injected into your body. That is chemicals that in the bullet or pipette can go in right away. Okay. And when we finish the lab work, what to do? We get rid of all the waste by pour down to the drain. And let's go to environment. So if you work with the traditional one, that is 100, 200, and many students together is 1 liter, something like that. And you have to need for what? Pay for the waste disposal, the chemical waste disposal, which is expensive. I don't think that the school can afford that. So now you can see the second point, right? That why small scale chemistry can help, that allow the student to do by themselves without causing the damage or harmful to their body. The last group of chemicals that I will talk about is reactive chemicals. Because when you design the experiment, you use chemicals. I already emphasized that you must know the property of the chemicals before you design at the beginning, right? Right now looking at the beginning, you design the experiment first. So you have to choose or select the chemicals that is not harmful, and also you have to look at the possibility of the incompatible of chemical mixing together. So this is in this category we call reactive chemicals, which includes explosives, air sensitives, water sensitives, and incompatibles. Okay, so know the property of the chemical first, and you have to think about when you work, you plan first. Plan first. And you have to think about during working with the chemicals and how to store the chemicals, how to dispose. And suppose that there is